to begin our lesson on truncated. Bakit nasulat ko?
Uy, yun ba?
Truncated cylinders and prisms. And before we begin with equations, we have to understand the properties of truncated cylinders and prisms. With a truncated cylinder, we have a circular base and another non-circular upper base, which is tilted with respect to the circular base. And it has two edges, which are the longest and the shortest side. Now with the truncated prism, it has similar properties, except that this time, instead of circular, it's polygonal. We have a polygonal base and another which is not congruent to this and tilted in respect to the polygonal base. The equation for finding the volume of the cylindrical base at the truncated cylinder is KH, which is also the same for the truncated prism. The only difference is that the equations differ by their properties. K in this case is the right section of the truncated cylinder. Let's draw another cylinder. The property of the right section is that it's perpendicular to the lateral edges. Meaning, if you have a truncated cylinder which has no true circular base, we'll have to find a right section, and that can be found by finding the area of the base, area of this base, times the sine of theta to find this right section. And then we multiply that right section, defined here, to the average of the height. And since we can't find multiple lateral edges in the truncated cylinder, H is denoted as the highest edge and the lowest edge. The sum of those divided by 2. So then the formula for the volume of a truncated cylinder is K, which is the area times sine theta, which is the angle of inclination with respect to the base, times height 1 plus height 2 all over 2. And if you have a right truncated cylinder with respect to the base, and the lateral edge is perpendicular to the base, then sine theta is not required. The equation simply becomes V times h of 1 plus h of 2 all over 2, which is the average. Now if you have a circular truncated cylinder, the equation becomes, the formula for the base becomes pi r squared times height 1 plus height 2 all over 2. That is the volume of a right circular truncated cylinder. If it's an ellipse, it becomes pi a b times h sub 1 plus h sub 2 over 2. Now for the truncated prisms, the equation is different because there are multiple lateral edges. Say we have a right square truncated prism, volume becomes S squared times H sub 1, 2, 3, 4. All over the number of lateral edges. This basically is getting the average height of the truncated prism, as with the truncated cylinder. It's basically base times height, but in average. Now with the volume is equal to kh in the truncated prism, h is defined as h sub 1 plus h sub 2 ellipsis plus h sub n all over n, as given by this example. And k is equal to the base of, the right section of the truncated prism, which in this case is simply the base of the prism because it's a right truncated prism. Now to show examples for truncated prisms and cylinders. So we have example A, a truncated cylinder with its base 14 centimeters, with its base radius 14 centimeters long, with its lateral edges 50 and 30 centimeters at an angle of 60 degrees to the base. The equation for the volume is equal to is V equals KH, where K is B sine theta and H is 50, H sub 1 plus H sub 2 over 2. We can substitute the values. To find the base, it's pi times the radius 14 centimeters squared times the sine of 60 degrees times 50 plus 30 all over 2. This is equal to pi times 14 squared times square root of 3 over 2 times 50 plus 30 is 80 over 2 is 40. Then I'll skip to the answer, which is pi times 50 squared. Two one three 0.2805. The unit is centimeters, since its volume is cubic centimeters. That is the answer. For example D, we have a rectangular truncated prism, angled at 45 degrees respective to the base. So then we have to find the volume, which is KH, where K is equal to the right section of the base, B, which is B sine theta, times the height of the lateral edges, H sub 1 plus H sub 2 plus H sub 3 plus H sub 4 all over 4. The base becomes length times width of the rectangle, which is 5 times 13 times the sine of 45 degrees times 14 plus 13 plus 12 plus 11 all over 4. That's 65 times sine 45 times 25 over 2, which becomes 574.5254. No, 5243 cubic units.